Hello everyone, welcome to the course Geotechnical Engineering 2. So in this module number 5 and lecture number 5, we will be discussing on some other concepts related to the load carrying capacity. So before that, let us look at the course outline. So we are in the phase of discussion related to load carrying capacity related to the pile foundation. Later we will be discussing the pile load test along with a certain terminology known as the efficiency, and then if possible we will try to understand the concept of negative skin friction in this particular lecture itself, and then we will be discussing the concepts related to settlements considering the pile foundation and the other deep foundation that is there, and an introduction to well foundation. Okay. Now let us discuss the static method for board piles. Okay. So what exactly do we mean by these board piles? That means we need to carry out an excavation initially. That means we need to dig a borehole and then we need to immerse this pile. We have learned the classification initially. So that means these board piles are casted inside itself. That means after digging a borehole, then by pouring some amount of concrete, we are constructing the pile foundation. Okay. So here there are generally classified into two categories. One is the normal board pile. Normal board pile. So what do we mean by this normal board pile? That means if you consider any ground level and if a pile is laid up to a certain depth, say, okay, then such type of pile is known as a board pile. That means after excavation of a bored hole, this pile is immersed. Okay. So such type of piles are known as these board piles. So if you look at the other type, that is known as under-reamed piles. Under-reamed piles. Okay. That means these are a different types of piles which have an additional bulb sort of arrangement. That means if you consider this as a pile, for this particular pile, if there is an additional bulb sort of arrangement in this manner, okay, then such type of pile is known as an under-reamed pile. Okay. If it contains a bulb sort of arrangement, then such piles are known as under-reamed piles. These type of piles generally are used for more support. Okay. So a bulb sort of arrangement generally just above the tip of the footing or somewhere in between. Okay. So these under-reamed piles may either have a single bulb, okay, or double bulb or any n number depending upon the requirement. Okay. So depending upon the requirement of the number of bulbs, it may be either a single bulb or a double bulb, okay, or a double bulb under-reamed pile. Okay. So it may be any of this particular type. Okay. So the load carrying capacity of this such type of board piles can be determined in a similar way of that of the driven piles. However, only one small entity will be changing, that is the soil parameters will be changing here. So in such case of the board piles, whenever we are determining the ultimate bearing capacity, the soil parameters play a major role. Okay. So the soil parameters will be an additional factor that are considered, and the ultimate values, okay, ultimate bearing capacity values how we have determined in the driven piles are used. Okay. Now let us try to discuss these concepts. Okay. In case of sands, let us discuss the board piles in sands. Board piles in sand. Board piles in sand. Okay. So in this case, the determination of ultimate bearing capacity is similar to that of the driven piles, okay, in sand. So the equation will be capital QU is equal to Q dash NQ into AP plus sigma I equal to 1 to n, okay, sigma V bar of I into K into tan delta multiplied by ASI multiplied by ASI. So, this is the equation that we have obtained similar to that of the driven piles. The same expression can be used here in case of bored piles in sand. Okay. So, however, while driving this particular borehole in a particular sand, okay, so what happens is sand that is in the dense state or medium state initially, because of this boring, will tend to get loose. So, when it gets loose, so obviously what will happen? The phi dash value that is actually there, now it has to be used for the loose condition. So, therefore, this phi value whatever we are using for determining the bearing capacity factor, that is NQ. So, in this case we need to consider this phi value for the loose state of sand, for the loose state of sand. So, in this case while driving a borehole, so what is happening, the medium sand or the dense sand that is actually getting loosened. So, for this case the soil is getting loosened. So, that is why we have to consider the phi or phi dash value in determining the bearing capacity factor Q. In this expression we have to utilize the loosened state. Clear? So, we have to use this particular expression. Okay. However, the value of K in this particular expression, okay, it may be considered as 1 minus sin phi or phi dash. It may be considered 1 minus sin phi dash, okay, because this is the coefficient of earth pressure. So, considering this as not in active case or a passive case, it is directly considered at rest, and K is considered 1 minus sin phi dash. Clear? So, using these expressions we may obtain the ultimate bearing capacity in case of bored piles in sand. Clear? Generally this particular K value ranges from 0.3 to 0.75. However, of this particular range it is generally considered 0.5 for our convenience. Okay. And the value of delta, okay, in the expression, that is tan delta. So, this value of delta may be taken as phi dash. It is referred that this value of delta may be taken as phi dash. That means in this expression this tan delta may be taken as tan phi dash for convenience, because delta is similar to that of phi dash. Okay. So, in such way we will obtain the expression of Qu for bored piles in sand. Now, let us look at the other type, that is bored piles in clay. Bored piles in clay. Okay. So, here also a similar expression that is obtained for the driven pile in case of saturated clay may be used. So, here Qu is equals to CNC AP plus alpha C bar AS. Okay. So, we know this terminology. So, simply it is CNC AP plus alpha C bar AS, okay, where the value of alpha in this case is taken as 0.5 in general. Okay. In case of this bored piles in saturated clay, alpha value is taken 0.5. However, since this excavation is done prior to the driving of this pile, that means initially excavation is carried out and then the pile is driven into this borehole. So, whenever while driving this particular pile, so if there is any slurry added, so in such case then alpha will be taken 0.3. Alpha will be taken 0.3 whenever there is any slurry added. Okay. So, in such case whenever there is any slurry added, alpha is taken 0.5 and the values are determined. However, the value of C here is actually considered in a stiff and medium clay. So, that is why it has to be reduced to 75% of the initial value. So, it has to be reduced to 75% of the actual cohesion value. Clear? So now let us look at the other type, that is under rimmed pile in clay. Okay. So these under rimmed piles are generally used in case of a saturated clay. So if you consider this as a particular pile of certain width small b, and if it is having a bulb sort of arrangement at a particular depth, then such type of piles are known as the under rimmed piles. So in this case, let us consider the width of this bulb is b dash. Since there is only one bulb acting, so that is why it is known as a single under rimmed pile or single bulb under rimmed pile. So if it is having two bulbs, okay, in this manner, okay, then such type of pile is known as a double bulb under rimmed pile. Okay. So depending upon the requirement and the soil conditions, we may use such type of pile. Okay. So if you look at here, this width of the pile is now actually increased at a certain depth, okay, from b to b dash. So that is why in such case this QU is obtained as C NC into AB plus alpha C bar AS dash. Okay. So the only entity that is changing here is AB is considered for the area of this bulb. Okay. So here if we have to obtain the expression here, on further simplification it will be C will be in this manner, and NC in case of saturated clays is considered 9. So it is 9C into pi by 4 into, let us say the width is b square, okay. And in addition to this, to find out this AB, it is considered as 9C into pi by 4 into b dash square minus b square. Okay. Clear? And this will be plus alpha C bar ASI. So in such way, the value of QU, the ultimate bearing capacity in case of under rimmed pile, is obtained in this manner. Okay. Where this area AB is taken as pi by 4 b square plus pi by 4 into b dash square minus b square. Okay. That I have simplified and written separately. Okay. This term is simplified in this manner, because in case of saturated clay, this value of C is generally 9. This we have discussed in the previous session. Okay. So substituting 9C into pi by 4 d square b square plus 9C into pi by 4 b dash square minus b square. Okay. This will be alpha into C dash into ASI. Okay. Now let us discuss the other topic, that is skin friction resistance. Okay. So skin friction resistance. So if you consider this is a ground level and this is a particular pile foundation. So when it is driven into the soil, so what is happening? Resistance is offered in the opposite direction. Resistance is offered in the opposite direction. Okay. So such type of resistance offered along the surface is nothing but skin friction resistance. But here we need to understand, if there is any loose soil in this region, let us say, okay, let us say up to this region, this red color region, there is loose soil. Okay. Let us say it is a loose sand. So when this pile is actually driven into the ground, so what is happening? This soil which is stiff will try to resistance, but this loose soil will try to come down along with this particular pile that is driven. So that is why in this case the resistance is not offered, and additionally there is some frictional resistance coming along with the pile, okay, because of this presence of loose soil. So this opposite direction, this negative direction resistance force that is there is called as the negative skin friction, negative skin friction resistance. Okay. So in case of loose soil, whenever present in the ground, when the pile is penetrated inside the soil, so in such aspects what happens is a driving force along the pile direction may be observed, and such resistance is known as the negative skin friction, and this is obtained as Q u dash is equals to Qu minus Qnsf. Okay. We have obtained the expressions for Qu, but this Qnsf is obtained from this negative skin friction that is obtained here, okay, which is similar to that of the skin friction resistance what you are obtaining. This is similar to skin friction what we are obtaining, okay, but the direction will be in opposite direction. So that is why there is a negative sign. So that is why there is a negative sign. Clear? So in such way we need to determine the ultimate bearing capacity when there is any loose soil present, considering the negative skin friction effect. I hope this is clear now. Okay. So in the upcoming lecture we will be discussing on the pile load test related to this bearing capacity. Okay. So thank you very much. Have a nice day.